Okay, we have already more than 40 attendees, so if you're ready, we can start. Thank you.
Yeah, sure, I'm ready. This is, hello, my name is Just. Nice to see you all. This is my session around the traditional modern data warehouse. So, in this session, we will go through a couple of steps. And also, I want to tell you why I've been building up this session, because I'm hearing a lot about big data, big data, big data. And also, Microsoft is also very good at promoting the modern data warehouse and Synapse Analytics, but it's all focused on if you have huge data volumes. So I was wondering, could you use some of the same technologies in the cloud, Azure technologies, and build a simple solution and also a cost-effective solution for the SMB market? So with smaller data volumes, like 100 million rows fact tables and a couple of million rows dimension tables. So a solution at that size. And also taking the competencies that you have from building the same solution on an on-prem SQL Server. So if you have been used to using integration services and SQL Server on-premise, building your solution there, then how can we take the same skills and use them in the cloud in a traditional modern data warehouse? So I'll go through the different components of the solution, showing you some different architecture drawings, and also ending up looking at the price estimate for running a solution of this size in the cloud with Azure technologies. So first off, here we have the reference architecture from Microsoft. You can go in and find this on the Microsoft.com website. They have a whole lot of reference architecture, not just around data warehousing, just on every specific topic. But this is on the modern data warehouse reference architecture from Microsoft. So here you see that it is actually a traditional solution where you have some source systems in the one end, and then you have your Power BI reports and presentation in the other end. And you have there between your ETL flow. So extract, transform, load. Microsoft just call it something new there. They have to come up with something new. So they're calling it ingest, store, prep and train, and model and serve. But basically, it is just ETL, just as we know it. And in this architecture, Microsoft is saying use Azure Data Factory for your extract layer, so to extract from all kind of different source systems, and then store your data in the Azure Data Lake storage, and then prep and train. Yeah, that because this reference architecture is also not for just transforming data, but also for machine learning and artificial intelligence. And here they call it prep and train instead of transform, and they say you should use Azure Databricks. And then for the model and serve, they put in a component that's actually very, very expensive to use. This is the Azure SQL Data Warehouse. And on top of that, just an analysis services, as we know it from on-premise, also just the Azure variant, and then Power BI. Of course, it is a Microsoft reference architecture, so we have Power BI on top. This is the version 1. A couple of months or maybe 6 months ago, they changed it because then they rebranded actually the Azure SQL Data Warehouse to Azure Synapse Analytics. So it's the same service and for the model and serve, just a new name. Then just 1 or 2 months ago, they actually announced the public preview of Azure Synapse Analytics workspaces. That's a whole solution that is actually covering all or most of the parts in this. But they haven't updated the reference architecture yet, so this is the take on that. But I believe there will be a version 3 of this reference architecture where we have Azure Synapse Analytics also as the prep and train, and we also have a data factory as part of Azure Synapse Analytics. So it will actually be more simplified in the future when Microsoft decide to update this reference architecture. But this is the architecture as it looks like now, just standard ETL with the Microsoft different Azure components, and not all Microsoft different Azure components, because Databricks is actually not something that's built by Microsoft. But this is for big data. This is for huge data volumes to transform a lot of data from unstructured data sources, structured data sources. But how about if you just want to do an ordinary traditional data warehouse solution, which components from this reference architecture can be then used? So I've simplified it and come up with this one. So here you see that we don't have a data warehouse, we don't have Databricks, and I'm going back to more of the traditional naming with extract, transform, and load. And here you can see we are using Data Factory, that is integration services in the cloud, you can say. That is the service for extracting and ingesting data from various data sources. And then for transforming, I suggest you use a SQL database, not a data warehouse, not a Synapse or database, but a traditional SQL database. And then you can use the data lake for storage or for the archive. And then loading your data and serving your data from Azure Analysis Service and presenting it in Power BI. So this is the components from my perspective for doing a traditional modern data warehouse solution, but with Azure technologies. And I will go through in this section the different parts of this and how I'm using it in this architecture I've come up with. It's actually built on a project I did 1 year ago. So it is not something that is just theoretically, it is a practical solution I've made this session based on. And just one more note before we go is that Microsoft is now pushing that we shouldn't use Azure Analysis Services anymore going forward. Microsoft is blending in Azure Analysis Services and Power BI into one service, because Power BI actually have a built-in analysis services engine. So you can actually just load your data directly to Power BI and then save Azure Analysis Services, because Azure Analysis Services is actually one of the more expensive services you can buy. But you can, there comes some limitation, and I will come into that when we come to that part of the presentation in Power BI, if you use that for your serving layer. You can, of course, also use this one. It's not that Microsoft is deprecating Azure Analysis Services now. It will be there now, and I believe 5 years ahead. But if you want a more cost-effective solution, you can base it on directly on Power BI, and also more simple solutions. So you can see here, I only have 4 different components in this solution. So yeah, and please, if you have any questions throughout this session, use the Q&A feature of the Zoom platform, and I will keep an eye on it. And also, I have time in the end for questions. So, taking this, this was based on the reference architecture of Microsoft. Now I put it in a more simple architecture. You can say, so we have our data sources, the same. We use Data Factory as ingest engine, and then we store the data in a SQL data warehouse, transform the data in SQL data warehouse, and then serve it as part of the analysis service engine in Power BI and visualize it in Power BI, but also in other solutions like Excel, for instance. Or if you want, you could use Tableau, Click, another client tool that can connect to analysis services. And then we can use the data lake for archiving our data. So, but we can actually use this in two ways, because we can also use data lake as our storage engine. And I'm struggling actually myself if this is the better solution or this is the better solution, because we have here, if our data is coming from very structured data sources from Navision or another other database system, Dynamics or for instance, then we have the structure, well-structured data. Then we can use Data Factory just to load it directly to the SQL Server and then transform it. But if our data sources is more exotic, you can say, if they are more unstructured, if it's JSON files or APIs that is not just fitting directly into a table, then this architecture might be a better solution. Or you can do a combination of the two. So some of the data you directly ingest in your data lake or ingest it directly into your SQL database. But it is depending on if it's structured or unstructured, and also if you are in control of the ingestion, then you can ingest it directly into SQL Server. But if the data is delivered by your supplier, then you could have them just put it up and deliver it in the data lake, and then you can take it from there and transform it. So yeah, both solutions absolutely is good to do. So now for the rest of the session, I will go through these different components and tell you a little about it, and then show how I'm using it. And before I go on, of course, in the bottom of this architecture, I have Data Factory as the orchestration engine. So this is the engine that is calling, now go ingest or extract the data, now go transform the data, now go load the data. So it is the ETL process. I'm using Data Factory also for that part. And then we have Log Analytics or Azure Monitor as the way where I'm storing monitoring information. So all the logs of what is happening on the system, we can store them in Azure Monitor. So we have a place where we can go and find the logs here. So yeah, going through the whole solution. So the different components. We actually only have these 4 components: Data Factory, Data Lake Store, SQL Database, and Power BI in this solution. So Data Factory, I am talking a little about it, but this is the, I would say, standard way of executing or copying data, transforming, orchestrating data. This is integration services as a cloud service, you can say. But Microsoft has built it entirely from start again. So a lot of the things that you can really be mad about in integration services, that they are not here anymore. If you have used integration services, all this with metadata that you have to update all along down your pipelines, that is not anymore. So Data Factory is a really, really good solution, and it comes with 80 plus connectors for both cloud and hybrid. So you can copy data from your on-premise environment if you install an integration runtime like a gateway, but you can also copy from a lot of different cloud services. So it is the preferred way of copying data from your sources to your staging layer, whether it is directly into the SQL database or into the data lake. And you can also use it for orchestrating, and I will come back to that later. But you have a lot of functionality, and Microsoft is really committed on Azure Data Factory. You have new features coming in maybe every month and making the life for us as developers easier. So, and a lot of this is around you can use this built-in generic solutions. So let's have a look at this solution. So here I'm logged into the portal, the Azure portal, and I've created a resource group. And in this resource group, I've created the different resources that is part of this solution. And at the first most one is, or the topmost, is the Data Factory service. And here, going into Data Factory, I have opened up my development environment in here. And the first thing I want to show you is how to create a generic solution to copy data from a source system to your database. So in this demonstration, I'm using Databricks as a source database that is also on an Azure database, but it could be a lot of different. And I'll just go in here and show you the different services that we can. It's called a link service, but it is, yeah, just a data source. And in here, you can see all the different kind of systems I can copy data from and to. Here you have, yeah, I would say all your need for, yeah, and also you can call REST APIs and stuff like that, and ODBC connections. So just to show you that, and in here I have created, just let us see, here I want to copy one table, just one table from a source system, and in here I have a source data set, and this what is special here is that I have put in parameters in here so that I can specify a specific table name and schema name, and then this pipeline is then generic, and I can use it to copy not just 3 tables but 100 tables, and not being, if you come from integration services, you could use BIML as a service to multiply and create these extract packages. But here in Data Factory, you actually just need to build one pipeline, and then you can put parameters in and specify, yeah, this is the source. So this is pointing at my Databricks database as the source database, and then as the sink, that is just a new word for destination. Yeah, Microsoft love to call it new names. And here I'm putting the data in the SQL database I have built for this solution. And also here I can specify the table name, but here I have been putting in all in this schema that is called ext edv. And then we have an option to say, okay, pre-copy script. And here I can then put in some a parameter again, and then truncate the table at first. So I'm not archiving anything here. I'm just, yeah, truncating the data and then putting it in. If I was putting the data in the data lake, I will just keep the history, one file for each day or each hour I run this system. But here I'm truncating and putting in. So this system is designed that way, just to keep it simple. But of course, you can be more advanced here. So one pipeline here, and then I can call this pipeline as part of another pipeline. So I have for each table, and in this for each table, I have references this copy pipeline. But before that, I'm getting a list of tables. So I'm looking up which table should I copy. So I could hard code this list in here. That was one opportunity, but I could also get it from a table, and that's what I've done here. And also, just for having it very simple, I'm just looking at the source database and seeing, okay, give me all the tables that is in the sales LT schema. So you can see, just preview this one. And you can see here, there's not that many tables. And I get the list, and then I can go for every table. So let's have a look at this one, and then just run it. Yeah, and I can look here, and it's starting up and getting the list. I can see here, yeah, it's getting the list here. And then if I refresh it, it's going in and executing the pipeline. And we should see here that it's then getting a lot of different I was getting a warning saying executed sequentially, but I can also go in and define the batch count and then set it up to do a parallel copy. That will, of course, be more effective instead of doing it sequentially. But this is set for sequential load, and you can see here for ones I'm getting for every table. So this is the concept around using Data Factory as your ingest engine in a data warehouse solution. So going back to the slides, covering Data Factory as the ingest layer. So the next part is then the Azure Data Lake storage. That is a data lake where you can put your archive data, or and this is one of the advantages is that it's so cheap. It is so incredibly cheap that you should have. It is a solution. It is a service built for massive data volumes. So using it in a scenario like this, with maybe tables with 100,000 or millions, 100 millions of rows, then it won't cost you much. But if you could use it for your archive layer, so you have an you can go back in history, so you have the archive for every time you did an extract from your source systems. And here in the example, you can see if I place the data in my data lake storage, I can partition it and then have a file. I can save it as CSV files and then have a file for every day I did a load here, so I can go back in time and see how data has changed, and not like in the solution you saw here where I truncated the data and then didn't have the history. So this is a component you can put in your solution if you want that kind of feature, having an archive of your source systems. So, and it can handle structured, semi-structured, and unstructured data. So in my scenario, AdventureWorks is very structured. I can put it down in CSV file, but it could also be JSON file, XML file. It could be images and stuff like that, depending on what sources you are getting data from. I don't have a demo on this because it's pretty simple. So the next one is the database, the SQL database. And this is a database as a service. It is just like a traditional SQL database that you know from your on-premise, and you have all the features there. And one of the big advantages here, you don't have a specific version of SQL Server. You always have the latest version. So whenever Microsoft come out with new features, you will just have it. You don't need to wait 1 year or 2 years to get a new version of SQL Server. And one other big advantage here is that you can scale it. So you can have a small one in daytime where you're not using it. And then if you are doing your data warehouse load every night, once a day, then you can scale it up to a bigger one so that you can crunch or transform your data and then scale it down afterwards, and only paying a certain amount of money when you're actually using it and not paying when it's actually idling. So, and you have it in two different variants here. You have a DTU one and a vCore. And we started with having these DTU versions that can actually be scaled up to, in this example here, it is P15. But you can also have a vCore based database that is more like you know it from, or performance wise, from your SQL on-prem system. So in my scenario, I'm just using the DTU based with the number of rows I have. But you can, if your solution, so this is also one of the big advantages, not that you just can scale between the day, but also on time. So if your solution is growing and growing and growing, you're getting more and more data, you're sourcing more and more source systems into a data warehouse, then you can grow and you can start with a DTU-based database and then convert it to a core-based model afterwards, and then have a solution that can handle hundreds of millions of rows easily with a SQL database. Let's go in and have a look at that in the portal here. Here I have my database. It is a database, and you can see here as the configuration I have already started up. Here I'm using the standard S4. That's 200 DTU. And what is a DTU? You can have an explanation here. And here it is as simple as just going down here and saying apply, and then I'm not, now it's Danish kroner, sorry for that. I will have, in the end of the session, I will have the prices in US dollars, but you can see the price is going up when I'm getting a bigger one. And I can go up to S12 here, and then I can go to premium, and then later on, huge data volumes, I can go to vCore based. So this is the really beauty of this one. And it comes with an SQL Server Enterprise license built in. That is part of what you pay. Is you're paying for this for whenever you're using it. So SQL database. So how do we use the SQL database? Yeah, I use it as the engine for transforming my databases. So here you will see that I've zoomed in the database and then zoomed out. So I still have my data sources in the one end, and I have my models and data flows in Power BI on the other end, my analysis services here. So I have built a layered architecture, I will say, that is also pretty standard in data warehouse solution, nothing new here, where I'm having an extract layer, and staging layer, a baseline layer, and then a presentation layer, and then a couple of layers in the bottom to handle metadata, input, and logging. For instance, I could have a table here in my meta layer where I will say which tables should I copy, instead of just saying, look at the source system, copying all. Then I can handle in here and then specify, because maybe there are 200 tables in the sources, I only need 50 of them. Then I can have a table in my media layer here telling me what table to extract and use in my generic data factory pipeline to copy the data from this source system, and then have, of course, for different source systems. But the principle is in here is that we unload the data from the data sources directly into the extract layer, where they are one-to-one with the source system, and then we start the transformation part. And in some cases, you will need, before the end in the presentation layer, there you need to have the my baseline, I should say, that is where I'm storing the data as facts and dimensions. So I can go directly and transforming my data from extract to baseline. If it's really simple things I need to extract, but in some cases, maybe I want to reuse some of the tables I have been extracting, some of the logic, then I can place it in a staging layer and then doing it in, and then transforming it again and putting it in my baseline layer before it ended in my presentation layer. I would say my presentation layer is just a virtual layer. It is just views that is pointing at the table in the baseline layer. But in extract, staging, and baseline, that is persistent data. And the layers here is basically just different schemas. So let's have a look at how this looked like. So going into Management Studio, here I have connected to my database, to this URL or to the connection string that I found in the portal, and it's behaving just like an ordinary SQL Server here. And you can see my extract layer here. There I have a schema called ext_adv, so I can have a different schema for different source systems, so I can easily find the table or objects I need here. So that's my extract layer. That is what is actually auto-generated. You can have Data Factory if you are going from a system that is structured like another database, then you can have Data Factory actually auto-creating the tables. And I unfortunately didn't show you that, but it's just a click and then it is also generated. And here I don't have in my baseline layer, it is very simple solution here. I only have one fact table, and then I have a product table and a customer table that is then generated out of data that is in my extract layer. And then I also have in the bottom my stage layer sales. So how do I then get my data from the extract layer to the staging layer, or from my extract layer directly to my baseline layer? Yeah, actually pretty simple. I have created some views. So my transform logic is all in different views. And here you see I have my DMV views. That is for my presentation layer. That is what I said, that my presentation layer is just views directly on my baseline layer. So where I have my transformation is in the 4 bottom views, where I define how my sales data should be transformed. So taking this view, I place the view in the extract layer here, and I can script it so you can see that this is a very simple view, not much transformation going on here. Only transformation that is going on is I'm joining the sales order details with the sales order header. But I could go in here and do kind of transformation with cases and convert and cast and stuff like that on what I need here as business rules to be implemented in this sales table. So for my customer, I actually have a little more functionality in here. No, I didn't, sorry. It is in my product table. I have placed some logic in. And as you can see here, this is joining 3 different tables, and it is using a coalesce function and then renaming some of the tables. So not much transformation. But it is, if you have a background as a SQL developer or can write SQL, then all the transformation is based on views. So then the next question you can ask, okay, how do these views then get placed in these tables? Yeah, I've created some generic stored procedures. They are down here. So I have created one just called update table, a generic stored procedure that is taking some parameters in. So it is having saying, okay, which table should it update? So what is going on here is it is getting here is truncating the state table and then inserting into the state table what is getting from this extract view that is in here. Now it says table, but it is saying, okay, copy what is in this view to this table of the same name, just from one, as you can see. So it's copying from the extract layer until the staging layer. So that is the logic here, and then there are some more logic around doing some logging. So saying, okay, now I started this task, now I ended this task, and how many rows did I process as part of this task. Similarly, I have one for fact and one for dimensions. Let's have a look at this one as the fact one. Here again, truncating, inserting from not much different in here. And the same with my dimension tables, a little more sophisticated as it's generating the SQL in a little different way. But still, again, it is just copying data from a view to a table generic. And the whole concept here is that we are doing it a full load. So this is truncating and updating. This framework could easily be updated with merge functionality if you wanted that one. But this is just to keep it very, very simple, just to see that all the logic, transform logic, is just around views, making it very, very easy to implement new changes, new business rules, new columns and stuff like that. All transformation is done in plain T-SQL, not any fancy Databricks stuff or anything like that. Just plain T-SQL, and so yeah. So this was the transform framework in SQL database that places the data in views in the presentation layer. So next one is then serving it with Power BI, and this is where I started saying, oh, Power BI is also analysis services, and that's because inside Power BI we have this WordPad engine that is completely the same as we have in Azure Analysis Service and also in on-prem SQL Server tabular service. And it has this XML endpoint that Microsoft now opened up. This is, I believe it 2 years ago, Microsoft announced that they will emerge these two technologies. And we have now, actually, it is fully working. So you can use analysis services with and deploy a Power BI model with the XML endpoint. There are some limitations in this regarding if you are using only Pro or you are using Premium. If you are using Pro, your models can only be 1 GB in size, maximum size for every model. If you are using Premium, you have, whatever your premium size is, you can have it up to that. It could be 10 gigabytes or 25 gigabytes, 100 gigabytes per model if you pay for premium. But if you're just using and doing a simple solution, a small solution, you can actually have a lot of data in 1 gigabyte because it is compressed as part of one of the features in the Virtupack engine inside of analysis services. So you can actually have millions, tens of millions of rows in your fact and dimension tables and still have it on 1 gigabyte, I will say. So nothing problematic here. Then there's one thing, because if you are creating your analysis services models in either Tabular Editor or in Visual Studio and not using Power BI for creating your tabular models or analysis services model, then you need to deploy them. So how do you deploy them? And for that, when you want to deploy Power BI or analysis services to the Power BI service, you need premium functionality or capacity, Power BI capacity. And you can also buy that in the Azure portal. You can buy what is called an A1 capacity, and you just pay per the hour. So you can say you can open up for the XMLA possibility to deploy your models, and then closing it down again and only paying for just 1 hour when you're deploying your models, and then still just paying for Power BI Pro as your own license. And then when you're deploying new models once a week or once a month, you're just opening up the XMLA endpoint. I've written a blog post around using that functionality. But you can also now, with Power BI Premium per user license, you could also use that for using the XMLA endpoint. I'll just quickly show you. I have here a tabular model or a Power BI model in here. I could go in and then say, oh, publish this model. But then, this is the self-service way of publishing. But we are wanting to do really pro Power BI or pro analysis services development. So I can open up Tabular Editor. And now I have opened up the same solution in Tabular Editor, and I can go in here and then actually save this one. So I can say save as, and then save it as a tabular model file. So a file that I can actually open in analysis services. But what is even more cool is that I can go in here and then deploy it. And normally I will deploy it to a SQL Server or analysis services. But in here you can see that my endpoint, my server name is Power BI. I'll just go to here. Let's see. Here I have a workspace called IT Managed Datasets that have premium per user, but it could also be A1 capacity. And in here, when I go to settings, I can go to premium, and then I can get the workspace connection. I'll copy this one, and then going over here and paste it. And now I say, oh yeah, take this solution and deploy it. And I already authenticated, and I will say deployed under a new name, just so you can see that I'm not cheating. Deploy this solution, deployed, and now in the background we should see that there will come, and woo, it came another analysis services model. It's called a data set in Power BI, but it is analysis services model. I just deployed with using the XMLA endpoint, and then deploying the pro way. So serving with. Then the next up is then the orchestration part, because now I showed you how I build up the ingestion, the transforming, and also deployment of analysis services. But we wanted to make an ETL pipeline. So in this example you see here, I'm using Data Factory as my authoring solution. And in the first step, I'm calling the REST endpoint for the SQL database, and then actually moving the slider I showed earlier, but using it programmatically instead. So saying, okay, now scale up the database, the SQL database, and then I can execute different pipelines to copy data from different source systems into the database that is scaled up. And I can do this parallel, both inside the one system and also parallel between different source systems. Then I can call a pipeline that is transforming my data warehouse. So calling the different stored procedures in my data warehouse solution. I will quickly show you that one. And then I can then load my data, because this is the copy that is my extract, then transform, and then load my data to a Power BI dataset. So refreshing the Power BI dataset that is analysis services model, or I could also refresh Power BI data flows if I want that, also doing it programmatically. And then when I'm done with my ETL process, I can then scale down my SQL database once again and then save some money. Because if this could run maybe on 3 hours, then for the 21 other hours in the day, I'm not paying so much money. I can't turn it off my SQL database, but I can scale it very, very down to pay small amount of money. So let's just have a look at my transform. Here I have my pipeline that is calling the different stored procedures I have in my database. So this is my transform pipeline. So calling the stage sales, this is just calling that stored procedure with a parameter. Then transforming products, customer, transforming sales. That is basically this Data Factory pipeline doing. And then I have this master pipeline. This is simplified, scaling up my database, scaling down my database, then extracting, transforming, and loading. And quickly showing you the different, this is just different pipelines. This is my my scale functionality. It is just calling a web API or REST API, and depending, I have some variables here. So here you see, I can then say, scale it to an S0 or scaling to an S12. That was the biggest one I could buy, but specific server and database. So it's very generic pipeline here. My refresh Power BI is equally. I can call it just to have a, so you can have a look at it. So here it is refreshing a data set in here. So in a minute, you see, it started here. Now I'm refreshing, calling programmatically my load part of my my master pipeline. So I just call actually this step. Scaling up and scaling down. I can also show you now it's a set to S0. We can go in here and see it is set to S4 now. Let's just set it to an S2 and run it. So now it's starting up this scaling of it. And you can see here now, saying scaling in progress. So you can see it actually is working. So and then so this is the master pipeline doing it in the correct order, the different steps using Data Factory for this orchestration part. So Now I've been covering the different components in here. Now for the pricing. So how much does this cost if I wanted to implement this if you wanted to implement it in your company? So Microsoft has a pricing calculator, a tool. You can go in on the URL in the bottom of this slide and go in and then setting how much do you use the different components for which times, and then it will calculate the price. And as you can see here, my monthly total price for this whole solution is $110. That's not much money in my world, at least. So I'm having some stars, as I started saying, it's incredibly cheap. So here I set it to, I want 100 gigabytes of capacity. It's costing me under $4 a month. Yeah, pretty cheap. And then I have the SQL database, and I have it twice. That's because I wanted to show you that I have it placed in an S0, so the smallest one, in 640 hours. That is equivalent to 30 days by 21 hours. Yeah, 31 days. Yeah, but then I'm paying only just to have it as a service, 250 gigabytes. That's also pretty much database pretty much data I can have there. And then for 90 hours a month, so that's 3 hours per day in 30 days, I'm setting up to an S6. It could also be an S4 or an S8, depending on how much data you wanted to transform and how long it takes. It is pretty easy to just make some benchmark and try setting to S6, calling your store procedures, seeing how long does it take, setting it, and then on. But that's where the primary of the money is. Then Data Factory for both doing the copy activities and also for doing the orchestration, $10 a month, not much. And then Power BI Embedded, that is, in my case, I say, okay, I wanted to deploy for 10 hours a month. Then it is just $1 per hour. So depending if you already have Power BI Premium per user, yeah, you could just use that, and then you will save this $10, or you can pay for this A1 Power BI Embedded capacity, and then just turn it on when you deploy with Tableau Editor or SQL Server data tools, and then turn it off again afterwards. Pretty simple. And then I unfortunately didn't have time to show you, but then you can have Azure Monitor as part of this solution to save all the loggings you can on different components in your data portal in Azure. You can enable logging to Azure Monitor. So all Data Factory, what is doing, you can put it in here. I have a couple of moments, so I'm just going Data Factory and show you. Data Factory comes with its own monitor, but here it is saving all my loggings from my different runs. I'm saving them here, but I could also go in. I can go in here and then enable that these metrics should be also pushed to Log Analytics or Azure Monitor. I can do the same on my SQL database and then have it all in one central place, and then build some logging reports on top of it. I have, as part of logging, I also built in some logging inside the SQL Server. Here you can see that every time I call a store procedure, it is creating a log entry both on the task level and also on the pipeline level. And here you can see, actually, I'm also logging, in this case, the database was in a S4 or S3 standard when I run this specific pipeline, and I have a pipeline run ID, as you can see here, and this pipeline run ID is equivalent to this pipeline run ID you see here, so that you can couple the different logging if you want. at least. So going back to the slides, covering the pricing and also a little about the monitoring. It was here, yeah, just said custom logging on pipeline task level in the database, and then you can use Azure Monitor to gather data from different services, like from you can have it in, and then you can actually do Power Query on top of Azure Monitor, so you can make a Power BI report on top of your logging and showing you how your nightly run was and showing it over time and stuff like that. So Azure Monitor is a preferred way of saving your logging. So yeah, monitoring part. Questions? Unfortunately, we only have 3 minutes left of this session, but if you have any questions, please then contact me. I can see that I will let us my contact details. I can show you quickly here. You can find me on justb.dk. So if you have any questions, you can go in here and find my contact details, and also the code I showed you today is on GitHub. So both the data factory, I have saved the pipelines for how to call a refresh Power BI dataset, scale a database, and then also in here you have this different database objects, both the store procedures and views and stuff like that, based on AdventureWorks. But you can of course just download it and then build a proper or try it out or modify it for your needs. But it is part of this GitHub here. It is just the start of this GitHub. I'm hoping to extend it with more code. And if you have any if you have any recommendations or suggestions, please then reach out to me. I'm not sure how these slides are distributed, but I've included some useful resources. Yeah, you saw it here, my code on GitHub, the pricing estimate, and then the reference architecture. But I will figure out how I can share them with you. So thank you very much for attending my session here. I hope you learned something, or maybe you just saw this session to see that the way you're doing it already is the right way to create a modern data warehouse or traditional data warehouse. So yeah, and thank you for spending time on this session, and have a good rest of the day on SQL Day conference. So bye bye from Just in Denmark. Bye.